Hello and welcome for my video. In this video I want to tell you about multiprocessing in Python. And when you use Panda, you can use multi-threading. And in my case, I have 32 threads to do it. And if you do it on the old-fashioned way, you will only use one single thread, and it's not so good. And if you use apply on your data frame in Panda, you will gain a lot of more speed, so you can perform your single thread performance even better. But if you have a bigger data frame, like with 1 to 1.5 million or more, then I would recommend you to use multiprocessing, so you can split up the data frame to every single thread. So let's starting. I will create the first file. It's called part1 single thread. Let's call it normal. And I want to import Panda, sorry. And then I want to say import time it, and just so we can exit. And first we want to read our data frame from CSV. I have a small and a big one. The small have 100 rows and the big one have 1.5 million. And in this case we want to encoding it. Where I downloaded it from, it's not UTF-8, so we need to read it inside from the right encoding, else we will get an error. What we're interested in is to get the 4 digits in the credit card number, so we can group it by the 4-digit number, so we can use it for later using. Normally you have, I think it's 60 numbers in a credit card, but it's to split up the search when we need to search something. It will be fine to have the first 4 digits, and it's more to demonstrate my idea with the multi-threading. So in this case we want to say a column called start digits. We will say none because it's nothing inside right now. And then we use a start time. It's microseconds. So the first one, you know it already. And then we want the indexes. This way, it's if you don't have working so much with pandas, this way will probably be the way you make a loop, because that's what you know. It's nothing wrong with this if you have a low numbers of rows. And we convert it to a string just to be sure. I know my CSV is imported like an inch, because all my card numbers is integer, so nothing wrong. You can say when you import this big fit column, it should be a string, but I will demonstrate this so you have in a more effective way, because this one is not the best way to do it. And then we go back for our data frame, and I know this is 11, and we want the index, and we set it to first card number. And then we want to group it, group data frame, and group by start digits. And we want to say the size of group, just to print it out so you can see it. And you say this one, and let's print it out. and we want to say group data frame get group, and I know a card number starting with the 6011, so that's what we want. And then we say stop time. And round should be and we want to print it out now. Round time. And because we only have 100, I will make an estimate if we run it on 1.5 million. So multiply with 15000, and there should be min handle time estimate on 1.5 million works. So let's try this out, and can't find the app. Sorry, we run this file and something is wrong here. It's probably my spelling. Records, and we want to move this outside here, and that's perfect. Close the file down and run it again. Whoops. I will put inside here, not again. And what's wrong here? It's the wrong index. And we run it here. And you can see it's taking 0.05 seconds to run this handler. And if we're going to run this, it will take a lot more time to run. Let's do it again and run it one more time. And see, it will take around 12 minutes to run if we take this on the normal way. If you do it. So let's create a new file. We can call it part 2 single thread apply, and then we go inside here. And now we want to make an apply function. For this we need a function first. We can call it card handler and put x inside. X will be a field on the data frame. We will copy this one, and we will import this as the card number will be the x in this case, and then we want to return it. And we will remove this, and then we want to run the apply. And we want to say df card number apply card handler, and then it should run even faster. Card tickets, yes, this is the part 2. If you make an apply, you can see it's a little slower here. It could be a different reason for that, but normally apply will be faster. If you make the big one, I will be sure apply will be much faster. So let's go in for for the more interesting one is when we want to split it up for multi-threading. I would say part 3 multi-thread, and then we go for Python here. Refact. I can see I'm missing something. Yes. Then I paste my code inside. And for this, we need something to trigger a function. We put this one in and say if the name is equal to main, it should trigger this one. Let's see it's working. It's working as it should be. That's perfect. So when you need to run the multi-threading, we need a more package inside. The one we want, it's numpy, because numpy we want to split our array to pieces, so we can split the list into multi-processing. So we need the multiprocessing library. That's the 2 new stuffs you don't have used before. And then we need the card handler. We need a little bit different inside. And we will build the strip digits to make the handler. And I will put this inside here and make pass. So now we have moving it inside. You can even do it more fast here. And what we need is to build a paralyzed function. This is the data frame we want to send in, and this is the function we need to trigger. And what we need is the data frame. We have it apply function here. What I want to say, if the data frame is equal to data frame, the paralyzed data, the data frame, and the function we want to trigger, it's the card handler. In this case, we trigger out our function. We call the paralyzed with the data frame df, and then the card handler is the function. Inside a paralyzed, we of course need to call the card handler. Before we are ready for this, I discovered something weird on Windows. You need to set the multiprocessing. Whoops. Set start method, and should be spawn. If you don't do this, if this line missing, and you're working on Windows, you will hit the frozen threads error. If you're running on Linux, you can just comment this line out and nothing will happen, and it will work as it should be. So if you're running on Windows, remember this line. I need to know how many cores we have, because this will be how many threads we will run on, and we want to say partition should be the same as the core. And I think we're good to go for the next step now. We will build our paralyze. We want the data frame split, and in this we use numpy array split. If you don't have using numpy before, so just thinking about this, panda use numpy, so it will split your data frame into pieces, so it's easier for you to work with. So don't think more about that. And then we need 2 partitions. The partition is how many splits we do, in this case we will split it up in the equal to the threads. Normally I multiply the threads. If I know there's 1.5 million rows, I will split it up in like my threads count multiply 100 or something like that. And then we have the pool. We need to multi-threading pool. This should be the same as our cores, so we use every single core. Don't use more, because then you can hit the stock. If you have more than one thread in one thread of your CPU, you can get stuck in your CPU and your purpose will be very, very slow. And the next one will be the data frame, and we return, and we use panda concate. It's meaning we take the return data and put it together, and we use the pool and mapping a new function, the function we put inside with the data frame split. And we want to ignore our indexes. If you don't do that, in some cases this could be errors, and you can use a lot of time to figure out what happened. I basically just ignore the indexes and then set indexes later. And then we need to close our pool and return a data frame return. This code will return our processing. And then to the magic, we can just return this so you can see it. And let's say for fun we run it, or we run the wrong one, and we get MP the pool map, sorry, and then we have the links of the value. Something wrong here. Let me just see that. It's because we don't group by that. Okay, that's fine. Let's build it in the next level, of course. I think the mistake is because I'm not finished up here. Let's say x start digits should be equal to x card number, and then apply a strip digits. And let's run again. And no, something's still wrong. Apply. And now you can see everything is running perfect. And it should say it should taking a long time to run. And I'm trying the apply function again. I think I need to run this one. Yeah, you can see if you compare the normal one we want to run, it will take 0.05 milliseconds, around 40 minutes to run. And then we have the apply function. It will take around 3.5 minutes. And then we have a multi-threading function. It will take around 224 minutes to run. But it's because the way we do it is taking so much time across of the slow one. So now I want to say the big one. It's around 1.5 million, and we put this inside and multiply this with with 60. And we just say seconds. Nah, we take this, that's fine. And then I will show my cores GPU threads so you can see my machine, and split size and partitions here. This is the big one, and we run it again. It will take a little time, but it should take around 60 seconds to run all of it, and then we are done. It's very fast. Trying to run again. Yeah, we stop this one, and you can see the result here. It should take min. Yeah, we just removed the min. Now it's confusing, sorry. And we say sick to hand. Yeah, and we run it again. It should take very few seconds to run this. When it's starting running here, we can say what we want. We want to apply to 110. It's meaning we spawn more partitions, so every process running fewer rows. So maybe this will fix the low seconds down. But for now, it's almost 3 times each minute faster, so it's around 4 times minutes 12. It's 15 minutes times faster than the apply function already. So let's go again, run this one, and now we have splitting up with the 10 times more splits, so every process will have less than 10 of every split, and it can run faster, but it could take longer time. It depends on what it should do, but in this case it's taking a half second lower. So this is the video about how you can use multiprocessing in Panda. I will say, if you have few rows, only use apply. If you, like me, love to test with big data sets, then you should use all your threads to handle it better. I hope you enjoyed my video. You can subscribe my channel to get more videos of this type, and I hope you will like my video, share it to your friends, and make a comment if you have any question. I will try to answer you. Thank you for watching. Remember to subscribe my channel. See you.